Hi student, in this experiment is designed how a linear and a non-linear regression problem can be solved using Excel and Python. In this video lecture, I will solve how both the problem can be solved in Excel. Okay, prior to going to the Excel, I will discuss about what is regression with simple examples. Okay, if I have X and Y data, I have X and Y data. We know that in the school we have done that. That is, I can locate these X and Y value here like that. Okay, I can locate X1 and Y1 like that. You can locate all the points. So X1, Y1 is nothing but this value is X1, this value is Y1. Like that, I can locate all the points. The moment I have located, if I have been asked to fit in a straight line equation, I will draw a straight line. Okay, there are multiple ways to draw a straight line, but what should be the constraint to draw this straight line? Okay, the simplest way is I want to minimize this error. This is the vertical line. This is called as error. What is error? This line is I will always call this a predicted, and this value I will call as this data point I will call as actual. So the difference between the predicted and the actual value is called as the error, and after finding the error I will square the error. So I am going to call it squared error. Okay, so once I have X and Y, now we know the equation of straight line, that is y is equal to mx plus c. At starting, what we'll be doing is we'll be assuming m and c value some random value. Okay, then once I assume the m and c value, so I'll predict the value using the equation by assuming m equal, let me take m equal to 1 or c equal to 2. I'll predict the value of y value using the x data. Now I have y1 predicted, like that I have yn predicted. Then I will find the squared error, SE, difference between the y predicted minus y actual square. Then after doing entire thing, I will find sum of squared error. I will add the error, and after adding the error, that is called a sum of squared error. Now I need to again find the value of m and the c value in such a way that I can minimize sum of squared error. That's what we are going to call as a regression. Same principle shall be applied for the non-linear regression also. Okay, suppose I have the data points. I have to draw a non-linear equation curve in such a way that I can minimize the error. So simple example I am going to take today is y is equal to a exponential of b multiplied by x. So I'm going to take two problems and I'm going to execute in the Excel. Yeah, now let us go to Excel. Okay, here one thing you have to understand in Excel, we have a tab called data. Under the data, we need to import solver if it is not already imported. Okay, so that can be done. Click on the file, go to the options, click on add ins and select solver ins and click on OK. Check the solver add-in. Okay, then only the add-in function will be enabled in the Excel. Okay, now as I said, I am going to start with, let me start with my m and c value. Let me take this, m value is 1 and c value is the 2. Okay, now what is y predicted? That is equal to m value multiplied by x plus c value. Enter. And I want to copy the entire I want to copy this formula for the entire cells by double clicking on the square at the bottom of the cell, selected cell. Okay, double click on it, you will get the value. But actually, one things you have to observe is whenever I'm double selecting, you can observe here B4, this value is selected. Then, sorry, B4 is this value. Okay, so what happened is when I copied the formulas for the next cell, the Excel, what it considers is it move to the next value, next cell, as we can notice here. But what I want to do is I want to fix only this cell as a reference cell. I don't want to change the cell, but I want to change only this X value. Okay, for that, one of the options given in the Excel is you want to make it as a reference cell, insert dollar symbol. If you want to fix row as the reference, put the dollar in front of the row index. Okay, and if you want to fix the cell as the reference, you can put dollar. So in this case, I want to fix this as a static cell. So I have to insert before the B and before the 4. That is before the column index and before the row index. Okay, and here also I want to fix this cell as the reference cell. Okay, for that, let me do the modification here itself. So whatever cell I want to make it as a fixed cell, insert dollar symbol here for column index, also for the row index. Here also I want to fix this as a reference cell. So here before the column index, insert the dollar symbol, and before the row index, insert the dollar symbols. Okay, for details are given here. Suppose if you want to do the formulas A1 plus B1 and you want to extend to, if you want to copy the formula for next cell, automatically that reference cell will not be fixed. Okay, for that, if you want to insert dollar symbol here, and that's what I have done it. Okay, before the column reference I have to insert the dollar, and before the row. What happens if I am going to insert only dollar symbol in front of the A, the column A is fixed. Okay, if I want to insert dollar symbol in front of the row index, only row will be fixed. So these things you have to have the basic understanding. Okay, the moment I have done that formula here, okay, now just double click on it, and you can notice that the reference cell have not changed. B3 is the reference cell. What is B3? This is my B3 and this is my E3. Okay, and you can observe here the values of reference cell have not changed for all the rows. Okay, once I have predicted Y, I'll just take the, and I will find the error here. Error equal to this value minus this value. This is the predicted value, this is the actual value. Put it within the bracket and the square. So I want to find the square of the error. Okay, sorry, I have to put 2 power 2. Yeah, now I can double click or I can drag the formula to the entire cells. Now I have determined squared error. Now I want to find the sum of squared error. For that, keep the cursor here, equal to sum. Okay, and you can select this formula and you can select all the squared error, close the bracket, enter. This is the sum of squared error. Now I want to recalculate value of M and C by minimizing SSE, that is sum of squared error. Okay, prior to that I will plot the graph. I want to first plot the graph between X and Y. Go to insert, scatter, under scatter I want to plot scatter with smooth lines and markers. Okay, select that. You can observe that is a plot is selected here, and right click, add data, select data. This one is let me edit. This is the actual series name, actual. Okay, now I have to add the data. Let me select, okay, add, click on add data. Now here it is, what I'm going to plot is predictor. Okay, predictor, my x value, we know that the same for the both actual and predicted. My x value is this cells and my y value is this value. Okay, click on OK and you can observe that. Click on OK, and if you want to add legends, okay, click on the plus symbol and check the legend. Okay, and you can observe here we have a lot of difference between the actual line and the predicted line. Okay, and to minimize, as I said, I have to find the new value of m and c by minimizing sum of squared error. Okay, for that, go to the data. Okay, let us observe what is happening in the graph itself. Okay, go to the data, click on solver. Okay, in the solver, set objective. Okay, my objective is I want to minimize sum of squared error. Okay, so you have to select this cell, that is a D12. Then I want to minimize. Okay, so I have to select. If you want to maximize, you can select maximize or minimize, or if you want to give the particular value as 0, okay, or whatever value, you can do this option. You can check this option. Okay, now I want my objective is I want to make it 0. It is not possible to make it 0 in some cases, so I want to minimize sum of squared error. Okay, and minimize and now I want to minimize by changing this cell, comma this cell. Okay, I have selected both by changing my m value and c value. Again, I'm just putting reminder, don't select this. Okay, this cell is a character. We have to select the value of c, that is given in the E3. You should not select D3, you should select E3. Okay, and click on solve, and there is a pop-up. It states that I have found the new value for m and c. Okay, I want to have the solved solution. Okay, click on OK. The values are changed here, and you can also observe here the predicted line almost close to the my actual or experimental value. Okay, and let us check with the Excel the default formula within the Excel. How to check that? Select our actual curve. Okay, I have selected. Right click on the mouse, go to the add trend line. Okay, and in that what you can do is just drag it down to bottom, display equation and chart. It is calculated as per the Excel. Okay, now the Excel throws the equation, that is y is equal to mx plus c, where my m is 1.7 and c is 0.3, same as what we have calculated through our minimization of sum of squared error. Okay, now I'll go to the how the similar kind of way how the non-linear problem can be solved. Okay, now I'll go to the sheet number 2. This is the equation I want to fit here. Again, I'll just predict. Okay, I can beautify my columns like by selecting that, and you can go to home, center, and I can give the borderline for my table here. I can give like this. Okay, and like that, and suppose you can select this entire row and wrap text, so that will be aligned. Okay, now I want to predict. Okay, that is equal to, just follow the same procedure I have done it for the previous one. Y equal to a. Okay, this is my a value. I'm not yet assumed. Okay, let me select that cell, multiply exponential exp p, you can select. Okay, exponential b, this value multiplied by my x value. Okay, close the bracket, enter. Is throwing 0 because I have not assumed the a value. Let me assume a value is 1. If no value is given, Excel automatically assumes 0. Let me give 1 and 2. Again, I want to make these two cells as a reference cell. For that, I have to modify. I want to make both column and row as a reference cell. Okay, so here I have to insert double dollars. Here also I have to E. Yeah. Now I can confidently drag the formula or copy the formula. Double click on the square, the formulas will be copied to the entire column. Okay. Now next thing I want to find the squared error equal to this value minus this value within the bracket square. Now drag the formula again. Sum of squared error equal to sum. You can select the formula thrown by the Excel and select entire squared error. Close the bracket. Enter. This is the sum of squared error. Again go to the data. Select solver. Objective function is, this is my objective function, and I want to minimize this objective function by changing this value comma this value, and that restore. Okay, and prior to doing that, let me visualize the graph. Okay, let me start again. 1 2 insert, go to scatter. Now you should not select with the straight line, you should select with the same thing. Scatter with the smooth lines and the markers. Okay, before that I need to select my data points. You have to select my data points. Okay, and go to scatter, and if you want to select straight line, the previous case I may have selected straight line. Now you can select the same thing. Now we have the smooth curve. Now I want to add data. Okay, add data, select data. So here let me edit first this one. Edit, this is the actual one, actual, and here x value is same. Okay, now I have to add data. My x value should be equal to predicted. X value should be this value, and the y value I have to select the predicted value. So I want to make sure that my both the values are closer. Okay, for that again let us go to the home. Same procedure, we can run it again. I'll just do it again. Data, solver, minimize D11, and by changing this one comma this one comma E2. Okay, solve. Okay, now you can observe that my predicted line is merged with my actual line, and you can again click on the plus symbol and you can add even legends. Okay, and the actual and predicted are also almost merged. Okay, thank you for watching the video. In upcoming video we'll discuss in the Python same problem.